Hello, beautiful people. My name's Watson, and today I'm going to be sharing with you a fun feature of Wireshark, namely how easy it is to replay unencrypted VoIP audio from packet captures, to further demonstrate how good of an idea it is to encrypt as much as you can. I'm going to be demonstrating this using SIP. And for those of you who don't know, SIP won the battle for dominant VoIP protocol. In the same way that VHS beat Betamax and Blu-rays beat HD DVDs, SIP won in terms of widespread adoption. And that widespread adoption means a corresponding level of attention and tooling development from the overall technology community. And one of those tools is in Wireshark, which I'll show you in a moment. My topology for this demonstration is here, and it's essentially two little simulated networks for the quote-unquote Los Angeles office and the quote-unquote Chicago office. It's really just two itty-bitty pfSense routers, two Raspberry Pis running Ubuntu 18.04 with Asterisk version 16, and two Yealink telephones. There's a stun server up here, because stun just makes VoIP work better. And my quote-unquote ISP is just a switch that I have. This is totally segmented off from the internet and all that. So yeah, let me show you the hardware. Okay, so hardware. We have the first phone right here in Los Angeles, extension 2270. Its corresponding office network, which consists of the pfSense, the Raspberry Pi, and a little 8-port Netgear. That WAN port of the pfSense goes up to this Cisco switch that I'm using to simulate the internet. Also plugged in is my little Ubuntu stun server. And then over here is the Chicago office, pfSense, Raspberry Pi, and 8-port Netgear switch, and extension 2340. So let's make a phone call. Pick up the phone here. Rings. Hello. Hello. World. World. Hello, world. And life is good. Or so we think. So let's say, unbeknownst to Alice and Bob, we're just trying to conduct business between two branches of their company, and unbeknownst to anyone within the company, someone had placed a network tap between their two offices and was capturing the traffic, running a pcap, listening in. To simulate this on one of the pfSenses, since it allows you to run a packet capture, I did so, and let's see how that looks. So here's a bunch of nonsense. We see a few SIP packets. We see even more, and then we see the RTP, the real-time protocol, the unencrypted audio. And here is where Wireshark has a handy little tool where it'll show you all the separate SIP conversations. Most of these are just the two Asterisk servers checking in with one another. Are you alive? Are you alive? Are you still there? Here is the call between those two phones that I just made. And right here, we have a play streams button. And sure enough, we have the two different audio streams.
Hello. Hello. World. World. Hello, world.
And it's as easy as that. So what do? Well, you can implement encryption. So the most straightforward way to do this would be to implement a VPN tunnel between the two firewalls. Easy. Fortunately, pfSense has a super easy walkthrough that I found. I'll share the link to that in the notes. So we just need to mosey over to the IPsec tunnel I built earlier, and to verify, we're going to start a ping. So these are SSH sessions between myself and the two Raspberry Pis. So we're just going to start a ping from one to the other and one to the other. And enable, and enable, and apply, and apply. And give it a moment. Responses. We are talking on LAN addresses now. Beautiful. We are not done though. We need to update the configuration in Asterisk to no longer try to peer based on public IPs. Because previously, the way this was working was just straight, old-fashioned NAT port forwarding rules, just like that. So 5060 for the SIP trunk, and then other rules just that I could log in from my laptop, which I assigned another 199 address. But we go back to the sip.conf file in Asterisk, and we're going to do a couple things. We are going to first tell Asterisk that there is another address subnet, an address space, that we need to consider a local network and therefore not use the public IP as the return address. We need to just, this is telling Asterisk, hey, tell 192.168 that I am also at to send it back to 10.1.10. whatever, as opposed to leaving the return address the public IP. So we update this. So this is Chicago. It needs to point to LA, which is 10.1.10.10. Add it to the permit IP .1.10.10. Right, and we go here. Four. Good. This is LA pointing to Chicago. Chicago is 192.168.1.10. And we write that change, and now we need to reload Asterisk. Okay. So let's see if we're talking. Beautiful. So now we can see that the LA PBX is talking to Chicago on a LAN address, and we should see a corresponding change over here. Yep. It sees the far end on a LAN address. Previously, this was just populated with the public IP, as you would expect. So let's make another call. And first, I'm going to start a pcap again. Unlimited length, and start it. Greetings. Hello. Two-way audio. Full duplex audio. So let's see if we can listen to that one. Okay, so let's download that packet capture and see if we can listen to the audio again. Open. Alright. And right out of the gate, you don't see any SIP data. You see a bunch of encapsulating security payloads. And in the SIP flows box, Wireshark doesn't see any SIP because it's sitting behind encryption. Beautiful thing. So there you go. Hopefully that has added something useful to your Wireshark toolkit, as well as provided some more understanding as to how Asterisk works. I am going to take these Asterisk config files, as well as a number of useful links that I ran into while I was trying to set up this whole sandbox environment. I'm going to bundle all those together. I'm going to put them on my GitHub. I will link to that in the description. And yeah, for next time, I'm going to set up another trunk between the two Asterisk boxes, but this time I'm going to implement encryption using TLS for both the signaling and the audio, so that if the VPN fails, for whatever reason, the Asterisk will fail over and send calls and still work and use the port forwarding method, but it'll still be encrypted. And I'll also set up a trunk to a little simulated ITSP that I'll spin up in my environment. So until next time, I hope you all stay safe. I hope you all stay happy. Take care of yourselves and take care of one another.